Hello and welcome to section 1.8, which covers perimeter, circumference, and area. So you should notice that a lot of this is going to be a review. And we'll throw in a few new things towards the end. So perimeter, very simple. You just walk around the outside and you add it up. It's the sum of the lengths of the sides of a polygon. So you're walking around the outside and you're adding it up. You label it just with like regular feet, centimeters, inches, whatever it might be. Area is the number of square units a polygon encloses. So the area of a square is just the side times the side squared. Area of a rectangle is base times height. Area of a triangle is half base height. And area of a circle is pi times r squared. Again, we should know all those. They're pretty basic formulas from junior high. The circle with B as its center can be named, this is a circle with a dot in the middle, B. Okay. Circumference of a circle. Circumference is just like walking around the circle, but because it is a curved line, you can't just walk around and add it up. You have to have a formula for it. So circumference of a circle is pi times diameter, or if they give you the radius, you have to double it first. So take the radius times 2 and then times pi. And pi is 3.14 unless they tell you differently. So if I was trying to find the circumference of a circle with a radius of 24 meters, again, whenever we use formulas, you always want to start by writing down the formula. So circumference equals pi times, and since they give us the radius on this one, I'll say pi r, not r squared, r times 2. So pi is 3.14. My radius is 24, and I'm going to take that times 2. So 24 times 2 is very simply 48. So 48 times 3.14 is 150.72 meters. And it's just plain meters. We do not put the squared on the end for the label. That's only for area and surface area that you do that. So on this one, if I want to graph the figure and find the perimeter of it, first thing you got to do is graph it. So -4, -1 will be at 1, 2, 3, 4, and -1. It is right here. Let me change my -4, -1 right there. And 4, 5 would be here and up 5. Remember that when you graph, you go to the left and right first. So C would be 4, 2. You go over 4 and up. Nope, it's -2, so down 2. So graph the figure and find the perimeter. To find the perimeter of this, we would have to connect the lines first. So here I have connected the dots, and I have resulted with a triangle. And so the easiest one to figure out is going to be the straight up and down side, which will be this one. And so we can just count the units. Remember, you count the spaces, not the lines. So here's a space, 1, 2, 3, 4, 5, 6, 7. So that was pretty easy. So then we can write that side BC equals 7. That was easy enough. To find B to A, that is not a straight line, so I'm going to have to use the formula for distance. So we're going to use the square roots. -4 minus 4 squared plus 5 minus a minus 1 squared. Where did I get these from? From these points. So if I'm doing B to A, I did -4 minus my other 4, and I did 5 minus 1, my two y's. So -4 minus 4 is -8. -8 squared is 64. 5 minus a minus 1 is like adding it, so it will be 6 squared, which is 36. If you add those two together, you get 100. And then I'm going to square root 100, which is 10. So then I know that side BA equals 10. That came out even, so that was good. Then I still need to do side AC. Again, we're going to use the distance formula. So I'm going to do -4 minus 4 squared plus -1 minus a -2 squared. Again, these should all be under square root symbols. I'm just trying to save time. -4 minus 4 is -8, and I need to square it. -1 plus a plus would be 1 squared. So here I have 64 plus 1, so 65 square root. And I'm going to round it to the 10th. So side, put it down here, AC equals 8.1 approximately. So the perimeter of that then, if I add all three of those together, I'm adding 10, 8.1, and 7. If I line up the decimals, it would be 25.1 units, whatever the unit is. I don't have a measurement. So there's my perimeter. So if you are designing a poster that will be 3 yards wide and 8 feet high, how much paper do you need to make the poster? We're going to give the answer in square feet. So it's just a rectangle. So area equals base times height. You do have to be careful on this one though, because one is given in yards and one is given in feet. So if I change the 3 yards to feet, that would be 9 feet because there's 3 feet in each yard. So then I could just very simply plug in 9 times 8. So 72 square feet would be my answer. That's a pretty large poster. Another example, diameter of a circle is 14 feet. So on this one, they're giving us the diameter, not the radius, so keep that in mind. What is the area of the circle in terms of pi? So area of a circle is pi r squared. So equals pi, and in terms of pi means leave the pi there, don't put 3.14 in there. So if the diameter is 14, my radius is 7, and I need to square it. So I would very simply just put, and I'm going to put the pi at the end, 49 pi square feet. In terms of pi means leave the pi symbol there. Don't multiply it out by 3.14. And the second part of that, what is the area of the circle using an approximation of pi? The approximation of pi is the 3.14. So area equals pi r squared. Area equals 3.14 times 7 squared. Go ahead and work that out, times 49. So the answer is 153.86 square feet. And I don't think it told us to round it, so I'm just going to leave it like that. So this and this is approximately the same answer. One of them you're leaving it in terms of pi, and one of them you're putting the 3.14 in there. The last part of this section, area addition postulate. So the area of a region is the sum of the areas of its non-overlapping parts. So there will be some figures that you're going to have to cut apart and find the area separately and then add it back together. This is one of them. And I need to draw the figure here. Okay, so here's my figure. So I have some congruence marks on there showing that all those sides that I have marked are 4 feet and then 12 feet across the whole bottom. So I have written up there already right here. I would just go ahead and cut it into a triangle and a rectangle because to me that's the easiest way. You could also use a trapezoid and a square if you wanted to, but I would just do this right here. I would cut this piece off, make it a triangle. And so since we know from here to here is 4 feet, what I have left from here to here is 8. And then I already know that that's 4. And wherever the right angle is, that's what you use for the bases. So the area of my triangle is half base height. And so I'm going to have half of 8 by 4, or 4 by 8, same thing. Half of 8 is 4. 4 times 4 is 16. So that area of that triangle is 16 square feet. The area of the rectangle, if I get rid of this because I already used that part, what's left is a 12 by 4 rectangle. And so area of a rectangle is pretty easy. Area equals base times height. So I would just go 12 times 4. So the area of that rectangle is 48 square feet. Then I'm going to add these two together and get 64 square feet for the area of the whole figure. There are many different shapes that you could do and just break them down like that. Bring that knowledge with you, and we'll talk about it more tomorrow. Have a good night.